All right, I'd like to make a little more clear the point that I just made at the end of the previous video 8.2a about how it doesn't matter what you call y equals 0 when you're dealing with potential energy. Remember the bowling ball. We lifted a bowling ball from the ground to the shelf, and then it had potential energy, right? Or it had more potential energy. And I tried to make the point it doesn't matter what you call 0. So we're going to do a similar problem here, again, in two different ways and take it a little slower. I feel like I kind of rushed it at the end of the last video because it was going on a bit long. So let's do it. Climbing Pike's Peak, you have 100 meters left to go, that in elevation. Okay, the angle doesn't matter. The fact is you're going to go up an extra, the final 100.0 meters. Now it turns out that Pike's Peak is 4,301 meters above sea level. All right, so here down here at the bottom, the wavy blue line is sea level. Okay? And so the question is, what is your change in potential energy as you go up? Okay, and we're going to do it the first situation. We're going to set, how do I have it worded here? We're going to set y equals 0 at sea level. So we're going to call for the first part, okay, the first part here, we're going to call this y equals 0. In that case, your final height is going to be y is 4,301 as advertised. Your initial height will be that minus 100 meters, which is y equals 4,201. That's your initial height. That's your final. Okay. And we're going to calculate the change in potential energy using our formula for potential energy of gravity, which is mgy. So let's do U final first. U final is going to be your mass, which I've actually got written here is 82 kilograms. 2.0 kilograms actually. It's going to be, right, mgy, mgyf, which is going to be 82 kilograms times 9.81 meters per second squared times your final height, which is 4,301 meters. And when you, this pen is really dying. When you do that, stick it in your calculator, you get a nice big number. You get 3,459,810 joules. That's a lot of potential energy you got there at the peak, right? At the final point. If you do the same thing initially now, with our 0 down here, you're going to get 82 kilograms. This pen, I'm really sorry, 82 kilograms. How's that showing up? Oh, that's okay. 82 kilograms, again, times 9.81 meters per second squared. Your initial height now is 4,201 meters. And so you're going to get, for this case, 3,379,000, comma, 368 joules. Okay. So that delta U, which is of course just UF minus UI. When you deal with your significant figures, you get 80,000 400 joules. Okay. That's the first case. we have put our y equals 0 here at sea level. So your initial elevation, your initial y value is 4201, your final y value is 4301. Plug it in, you find that you have increased your potential energy by over 80,000 joules. Now we're going to do a second case, and we're going to put y equals 0 at the peak. Okay. We're going to shift it around a little bit, and we're going to put y equals 0 up here. This is going to be our y equals 0. Okay. And we're going to do the same calculations. UF, your final, what's your final potential energy going to be? Here, it's going to be 0 because your final y value is equal to 0. So mg y sub f is going to be 0 because y sub f is equal to 0 no matter what m and g are. Okay. But if we do that, then your initial position, that's your final position, your initial position is going to be negative 100.0 meters because you're below. Okay? You're below 0. And so now, if you go to your initial, calculate your initial potential energy, you're going to have 82 kilograms times, again, 9.81 meters per second squared. But now your y sub I is going to be negative 100 meters because you're starting off 100 meters below 0, below what you called 0. Okay? And when you do all that, then you take delta U is the final minus the initial. Guess what you get? Yup, you get 80,400 joules. So these two are in fact equal. It doesn't matter what you call y equals 0. You're going to get the same delta U, the same change in potential energy both times. Again, just like the case with the bowling ball, the individual values of the potential energy, U sub F, for example, change. When you change your y equals 0 location, the final potential energy changed from 3.4 million joules to 0 joules. And your initial potential energy changed from 3.4 million joules down to I didn't actually put this number in. This actually is negative 80,400 joules. So the individual values, U sub F and U sub I, change when you change what you call 0, but delta U does not. And remember, delta U is related to the work done by, in this case, gravity. It shouldn't matter. It shouldn't matter. Let me put it this way: the work done by gravity, as you walk up those last 100 meters, should not depend on what you call 0, and it doesn't. It depends only on delta U, which doesn't depend on that, on where you call 0. Delta U is the same in both cases. And, you know, it doesn't matter what we call 0. Okay? The work done by gravity is going to be the same regardless of what we arbitrarily call y equals 0. Okay. And the work done by gravity will be negative this value, right? Negative delta U, negative 80,400 joules. Why? Because gravity points down, we went up. Okay. So our motion was upward. It opposed gravity, which is always down, so the work done by gravity is negative, as before. And that work does not depend on what we call y equals 0, because delta U does not depend on what we call y equals 0. The end of this video. See you next time.